So let's recap whatever things we have studied in the last class. Okay, so we have looked into this runtime. So what is runtime? Runtime is one of the class in Java. Okay, so which is used to execute some sort of commands. What is the method to execute a command? Exec. Exec is the method to execute a command. Okay, and runtime is not only to execute your command. Okay, so if you want to have the free space, I mean how much space is available in your virtual machine, okay, JVM, you can check it using a runtime. Okay, so how to get your free space? Just use runtime equal to runtime dot get runtime. Okay, and runtime dot free space is one of the method which will give you your space available in your JVM. Now then we have seen synchronization. What is synchronization? Synchronization is nothing but a mechanism by which only one thread can execute at a time. Okay, so I was giving you one of the example of your ATM machine. So if two persons are withdrawing money, okay, so you don't want both the person to withdraw the money. You want one person to withdraw the money. When he is finished, then second person will start withdrawing in the same account. I mean, okay. So if you want to achieve this sort of implementation, where you go for synchronization. So there are two ways to go for the synchronization. What are those? Mutual exclusive and cooperation. Now mutual exclusive can be divided into three parts. What are those? Synchronized method, synchronized block, and static synchronization. Okay, and what is the last one? So these are the things which you have seen. Then what is a lock? Lock is one of the property of object. Okay, by which what will happen? You can acquire it basically. So as soon as you will acquire the lock, what will happen? No other thread can work with that. As soon as you will release the lock, then only other thread will come and start working on that. Okay, so whenever you want to access the resource, first you put the lock, then access the resource. As soon as you are done the lock, you unlock it. Unlock means release the lock basically. Okay, so these are the two ways to do that. Now static synchronization. So what is static synchronization? Static synchronization is same as synchronization only. Just if you use the word called static, then it will become static synchronization. Okay, so I'll show you this. I believe which is sorry. Which one is this one? Correction. Yeah, here is the case. Okay, so I'll just close this other project. Okay, so if you remember, we were using one of the example called table where we are putting this synchronization mechanism. Now if you want to make it static synchronization, very simple. This is your block level synchronization, right? So you don't want to have this block level synchronization. You want to make it static synchronization. And what you write? Static, then synchronization. That's all. Now what will become? This method will become static synchronized. Same as normal synchronization only. What is the only thing? You just have to use that word called static. Then it will become your static synchronization. Okay. Now let's talk about one of the concept called deadlock. What is the concept called? Deadlock. So what is deadlock? Any idea what is deadlock? What? Telling something? What? Bolo. Okay. So try to understand. Like, suppose if we are having many threads. Okay, so T1 is one of the thread, and we are having T2 as one of the thread. T2 is one of the thread. Okay. Similarly, you are having many threads. T3 is one of the thread. Okay, and T1 is the one who is working with resource called R1. What is the resource name? R1. And to complete his task, T1 needs R2. You understood what I am telling? T1 is working with R1. To complete his task, what he need R2. Okay, and what T2 is doing? T2 is currently working with R2, and to complete what he needs R1. Are you able to understand what the problem is? So something like you are writing in your notebook, and I am teaching in my laptop. Okay, so you will tell me, sir, I need your laptop, and I will tell you I need your notebook. So will you give me your notebook? No, because we are writing. And will I give you my laptop? No, I am here teaching, right? So both are in deadlock scenario. I am also not giving, you are also not giving me. So similarly here also, T1 is working with R1. To complete he needs R2, and T2 is working with R2. To complete what he needs R1. So both are in deadlock scenario. He is also not releasing, he is also not releasing. So this scenario is nothing but deadlock basically. Okay, so it's not about two threads. If you are having multi-threads, then many threads are there. Okay, so in your college you might have studied one of those very simple way how will you do one graph you generate. Okay, so T1 is waiting for T2. Okay, T2 is waiting for T3. Okay, and now T3 again waiting for T1. Then what is happening? Again circular. T1, T2, T3, again T1. Are you able to understand? Then this is called deadlock scenario. So whenever you will have circular loop will come into picture, that will create your deadlock always. Okay, so some sort of graph I think you will generate in your college. Okay, so which will tell you whether there is some deadlock or not in your thread. Okay, so whenever there is some sort of circular loop, it will always be your deadlock. Okay, so now that's what we discussed. So if both the threads are waiting for each other to release the resource or lock, it's called deadlock. Okay, so both the threads are waiting for each other basically, to release the lock. Okay, so that's what. So T1 is waiting for T2, T2 is waiting for T1. So some circular loop is coming, right? So this is nothing but deadlock scenario. Okay, so now let's try to write one example which will help you out to understand what does deadlock means. Okay, so I'll go to my main class. And this one was for the synchronization, right? So I will just comment it. Okay, I'll write one very simple code. You have to tell me what will be the output. Okay, so I will write one code, thread equal to new thread. Okay, new thread. Okay, and one method if I want to overwrite. Okay, so okay, new run method. Okay, so what is happening? We are having one of the run method. So I'm creating my runnable also here only. So this is all nothing but inner anonymous implementation. Okay, runnable also I'm creating here only. Thread is also I'm creating over there. Okay, and similar to this, what I'll do, I'll create one more thread called thread 1. So there are two threads. What are those? Thread and thread 1. These are the two threads which are working. Okay, and here I'll print something called system.out.println. Okay, I'll print something like first started. Okay, then what I'll write? I will write first finished. Okay, similar to this, what we will write in run method. Okay, second started, second finished. Okay, and if you want to start, how to do? Thread dot start is the method by which it will start, and if you want to start the thread 1 dot start. Okay, so what should be the output? Tell me. Thread 1 start, thread 2 start. So order is not guaranteed. Why? Because it is thread. So might be first here, second here, first here. You don't know because thread means simultaneously it will work. Okay, so let's try to see the output. How many output we are getting? We are getting 4 output. First started, second started. Are you able to see? What you are expecting? First started, first finished. But what is coming? First started and second started. First finished, second finished. You don't know. I mean, it might change also. Let's try to see. So see. Luckily now what happened? See, second started, then first started, first finished, second finished. So as we know, thread will work in concurrent manner. You don't know the order. I mean, our order is not guaranteed. Okay, so it depends upon the running. I mean, the way how you run. You don't know. I mean, that is now what happened. First started, first finished, second started, second finished. So that is mode of the JVM basically. So our task is just to make it runnable. From runnable, how it is running, it is not in our control. Whose control it is? It is control of your JVM. Okay. So but it is guaranteed that how many output will come? 4 output will come. That is guaranteed. That is mandatory. Okay. Now I'll just slightly change my code. Okay. So I'll try to make it deadlock. Okay. So how will deadlock will always happen in the resource, right? So let's try to have one resource. So maybe I'll create one of the resource called string equal to, maybe I'll give one of the name called tapas. Okay, and second name is Chandra. So how many resources are there? Tapas, then Chandra. Okay, what I'll do here is try to understand. Okay, so I will try to have synchronized block here, synchronized block, where what is the first resource? String, means tapas, and inside this what I'll do, I'll have one more synchronized block called string 1. Okay, so first one is printing this first one, first started, and second one is printing your second started. Got it, right? So I am using two synchronized blocks, same as the previous class which we have studied, right? Similarly I'll use here also. Here also I'll write, but I'll write it in the reverse way. String 1 here I'll write string reverse. Okay, and here I'll do second started and second finished. Okay, and after starting first, what I'll do, I will make my thread for wait. Maybe if you're doing very expensive task, then what will happen? It might wait for very long period of time. So I'm just making my thread to sleep for some amount of time. Maybe for 1 second I'm sleeping here. Okay, and here also maybe. Now, how many output are expected? 2 outputs are accepted. 4 outputs are accepted. What are those? First started, first finished, second started, second finished. This is the I mean again, order we don't know, but you are very sure that how many output should come? 4 output should come. Okay, but let's try to run this code now. Okay, so if you run this code, see how many output are coming? 2 output. Where is other 2? Where are other 2? those are deadlocked. Those are deadlocked. Okay, so see from the code we'll try to understand what is it all about. Okay, so what happened is, when you started this thread equal to new runnable, thread is started. Okay, synchronize. What is synchronize? Synchronize means it will put lock in string and it printed first started. So where is your lock? String. By that time second thread also started and it has put in string 1. Got it right? And it has shown this output. So if we draw this diagram, what is happening? Our first thread T1 has put the lock on string and T2 has put the lock on string 1. Okay, now to finish first thread, what we need? String 1. So same scenario, R1, R2, what I was talking now. To finish T2, what we need? String 1, because next you are having work with that. And to finish T2, what you need? You need string. Are you able to understand? So what happens? Both the threads are waiting for each other to finish, and both are not able to finish. Why? Because he is waiting for the first thread, second thread is waiting for first thread is waiting for second thread. Basically, both are waiting for each other. So this is nothing but deadlock scenario. Okay, so just note this down. I mean the example which we have seen here. Okay, so first thread is waiting for Chandra and second thread is waiting for Tapas. So both are resource basically. So that's why they are not able to finish also, and they are not able to go beyond that. So that's why whenever you are using synchronization, be very careful. You might get into deadlock also. Okay. And why we are using sleep here? Because we are giving some time so that this line will execute. Otherwise, it will happen. If both lines got executed, then no problem, right? This thread will not wait because there will not be any resource which are not released. So we are giving a small bit of time to the thread so that this second thread should be executed. Okay, that's why we are using this sleep method. And second thread just reverse. Okay, here is string 1, here is string. So I want second thread to start with my second resource, the first thread to start with first resource. So in your college you might have studied only the theoretical part. So this is the practical where your threads might get stuck. is the second thread. So from the next batch who are coming now, so there are new things which are added, okay, which I did not, I mean, it was not there for you, okay. So you can go through those videos tutorials. I mean, some new things which are in 1.7, 1.8, okay. So all are there. So you visit your YouTube videos. 10, 11, 12. I mean, those are the new things which are added. Okay. Which were not there when you used to it. Okay, so now in written test or interview, one of the very typical question which comes. Okay, so what is that question? Question is very simple. Okay, so they'll ask one question: run method belongs to which class or anything, something like this. Okay, sometimes they'll ask sleep method, from where sleep method is coming. Okay, similar to this, some people will ask from where wait method is coming, from where notify method is coming. Okay, from where yield method is coming. Yield is one of the method. From where your yield method is coming. Okay, so this is very typical written test or interview question which you will be getting. Okay, so for this, I mean, we have to remember one small trick. Okay, so what is the trick is, one ad was very famous. What is the one? What is IIN? What is IIN? Any idea? Idea Internet Network, something, Internet Network, I think. Okay, so similar to this, not IIN. Okay, so we are having one of the shortcut called WNN. What is the shortcut? WNN. Okay, W for wait, N for notify all. What are three things? Wait, notify all. Okay, so just have to remember WNN. Okay, so WNN. Okay, WNN are, okay, part of object class. WNN are part of object class, and all remaining are from thread class, or it might be runnable also. Okay, runnable interface depending upon the requirement, but you remove runnable thread. Okay, for time being use thread. Runnable we'll discuss after some time. Got it, right? So what is shortcut? WNN. Okay, now if I'll ask you from where your yield method is, tell me. Thread class. Okay, if I'll ask you from where your wait method is, object class. Okay, if I'll ask you from where your sleep method is, thread class. Okay, if I'll ask you from where your notify method is, object class. You just have to remember this WNN, that's all. These are from object class, all remaining will be from thread class. All others, whatever methods are there in thread, all are from thread class. Okay, so now tell me from sorry, that's what it say. WNN. WNN will be from object class. All other will be from thread class. Run is the method which can be in both the place. Thread also, it can be on runnable also, depending upon your implementation. Why? Because there are two ways by which you can start the thread. What are those? The extending thread and implementing runnable. If you are doing implementing runnable, run method will be coming from interface. If you are doing extending thread, then it will come from here. Okay, so depending, so you just have to, you cannot remember, many things are there, right? So you just have to remember this wait, notify, notifier, WNN. WNN will be from object class. All other remaining will be from thread class. As simple as that. Okay, very typical written test question. Okay, so now okay, we'll wrap it up here only. Okay, next tutorial it will be finished, then we will start Android. Okay.